Log base 11 of 2x minus 1 is equal to 1 minus log base 11 of x plus 4. We need to find the value of x showing detailed reasoning. So first thing I'm going to do is to move the logarithms so they are on one side of the equation together. So I'm adding the log base 11 of x plus 4 to both sides. The reason why I'm doing that is I can now use the laws of logarithms to group these two logarithms together. We're adding the logarithms together. So I'm going to use the multiplication law, where the insides are going to get multiplied together. Like that. I can now remove the logarithm because I've got the log by itself. So the inverse of log base 11 is 11 to the power. So removing that from both sides, I'll have 11 to the power 1, which is just going to be 11. I can expand these brackets on the left-hand side to get 2x squared plus 8x minus 1. So no, minus 4. Collecting like terms, the 8x minus the x is 7x. Subtracting the 11 from both sides. Now to factorise this, it has to be a 2x and an x to get the 2x squared. To get the minus 15, I'm thinking a 5 and a 3. So if that was a 5 there, and that was a minus 3, then the 2x times the 5 is 10x, and the minus 3 times the x is minus 3x, so we get 10x minus 3x, which does equal 7x, so I factorise that correctly. So that's going to give two solutions of either 3 over 2 or minus 5. But if I were to substitute minus 5 in these original equations, I would get negatives. The minus 5 plus 4 is minus 1, and a logarithm is not defined for negatives. So this minus 5 is not a valid solution. It does say to give detailed reasoning, so I'm going to explain that here. I'm going to say not valid as logarithms actually I spell it right, are not defined for negatives. Not defined for less than 0. So 3 over 2 is my only answer. I can substitute 3 over 2 into both of these. If I substitute 3 over 2 in there, that's positive, that's fine. If I substitute 3 over 2 in here, that's going to be positive, that's fine. So 3 over 2 is the value of x.